This is mock paper number 1, question 1. Okay, it's a calculation question. Now, this question is a long question, right? Involves sodium percarbonate. This formula. Okay, so this chemical is an oxidizing agent in a lot of cleaning products. Now, uh, we look at this question, two parts. The first one is reaction between sodium percarbonate with acid. Okay, so I may write down. Okay, hold on. Let me change this. Okay, right. So let me write down the formula. This is sodium percarbonate. So inside the molecule, you can see that there's a sodium carbonate. Okay, we do not know how many. Okay, so they give us X. So there are X number of sodium carbonate in a molecule. Then there is Y hydrogen peroxide in the molecule. So it's a very complicated molecule. Now, this first paragraph is the reaction between sodium percarbonate with acid. So can you see you add acid, then this sodium carbonate will react with the acid to give us carbon dioxide gas. Okay. Then in another reaction, which is a titration reaction, titration experiment, uh, this sodium percarbonate is reacted with KMnO4, an oxidizing agent. Okay, and this KMnO4 will react with the hydrogen peroxide. Okay, then the endpoint is we get a pink solution. Okay, okay. Now look, both okay in both reactions, we are using the same sample of sodium percarbonate, same volume, same concentration. Okay, since we are given the volume, the concentration, we can find the number of mole of sodium percarbonate. Okay, we find the number of mole, which is CV0 1000, C concentration, times volume, divided by 1000. So 0.1 times 10 divided by 1000. So this is 1 times 10 to the power negative 3 mole. Okay. Now we are using same amount of sodium percarbonate in both reaction. Yep. So the first reaction, 48 centimeter cube of carbon dioxide is released. 48, yeah. So what's the number of mole of this carbon dioxide? Okay, I'll calculate the number of mole carbon dioxide here. Okay, 48 divided by 24,000, which is 2. Okay, 2 times 10 to the power of negative 3 mole. Okay, now let's look at the second reaction in the titration. 0.05 molar KMnO4, 24 centimeter cube volume is used, okay, to reach the endpoint. So again, we are given the concentration, we are given the volume. I want to calculate the number of mole of KMnO4. So 0.05 times 24. So I'm just converting everything to number of mole. So this is 1.220 times 10 to the power of negative 3 mole. Okay, you'll see why later when I calculate the mole ratio, then you'll see why I turn everything into number of mole, because using the mole ratio, I'll be able to find the ratio of y over x. Okay, now let's look at still in the second part. So it says that KMnO4 reacts with H2O2 in the mole ratio of 2 to 5. I found the number of mole of KMnO4. By using this ratio, I'll be able to find the number of mole of H2O2. So number of mole of KMnO4 divided by number of mole H2O2 is 2 to 5, right? So 2 over 5. So how do I find the number of mole H2O2? It will be 5 over 2 times number of mole of KMnO4. So I have here number of mole of KMnO4. So 502 times 1.2 times 10 to the power of 3. Okay, let's use calculator and do this. Sorry, missed out the closing bracket. Okay, it's 3 times 10 to the power of negative 3 mole. Okay, now we have everything. The number of mole of sodium percarbonate, the number of mole of carbon dioxide, and the number of mole of H2O2. Okay, so I want to write a table so that it's easier to see. I'm going to change the color of my pen. Okay, set to blue. So let me draw a table. I have 3 things. The sodium percarbonate, the very long formula, and write it smaller, X, Y, H2O2. Then I have CO2, and then I have H2O2. So this is 1 times 10 to the power of negative 3. This is 2 times 10 to the power of negative 3. H2O2 is 3 times 10 to the power of negative 3. So the mole ratio is actually 1, 2, and 3. So why finding this mole ratio important? Okay, is because I want to know 1 mole of this sodium percarbonate, how many mole of carbon dioxide will it release? Okay, if I have 1 mole of this, okay, it will release 2 moles of carbon dioxide on acidification. That means I have 2 sodium carbonate in 1 molecule of sodium percarbonate. So this one tells me that X is equals to 2. Because carbon dioxide can only be released from sodium carbonate. So how many sodium carbonate in the molecule? Then how many carbon dioxide I will get? Okay, now let's look at the mole ratio of sodium percarbonate to hydrogen peroxide. So it's 1 to 3. Now you see hydrogen peroxide is here, this part of the molecule. Okay, so 1 molecule, 3 hydrogen peroxide. Okay, that's why 1 to 3. Meaning Y is 3. Now we have found X, we have found Y. So what's the ratio of Y over X? Will be 3 over 2. So the answer to this question is C.